then go back to the whiteboard. New thing, I'm going to write my definition of one-to-one up here one more time so that we all have it in front of us. I have it in front of me. So again, we'll have F going from A to B, one-to-one, if for all X and Y living in A, X equals Y implies F of X equals F of Y, or F of X not equal to F of Y implies X is not equal to Y. Okay, so that's what we're working with. Proving injective. 1, 2, 3, 4. Somebody hold up fingers with her number for me. Which example we want to do? 1, 2, 3, or 4? Grant says 1. All right, here we go. For example, F, all of these are going to be prove or disprove that F is one-to-one. All of these are going to be prove or disprove that F is one-to-one. And we'll put my definition in a box up here so we can keep it. What I wouldn't give for an entire chalkboard. Okay, here's my first example. F is going to go from the integers to the integers, and X is going to be sent to 3X minus 4. F is going to go from the integers to the integers, and X is going to be sent to 3X minus 4. You are going to need to develop a feel for whether F is one-to-one and onto or not when we are doing F with the rule. So remember that a regular function has to satisfy the vertical line test in order to be a function, right? Vertical line test. In order to be one-to-one, it has to satisfy the horizontal line test. That's where this horizontal line test comes in. Everybody remembers the horizontal line test, right? If you draw a graph of the function and then you draw a horizontal line, it only crosses it in one spot. Give me a thumbs up that you remember the horizontal line test from high school. Yes, okay. So this is another way of saying, right, F of X is equal to 3X minus 4. What does the graph of 3X minus 4 look like? Graph of 3X minus 4 looks like what? We should know this. We absolutely know this. Line looks like a line. All right. So does a line satisfy the horizontal line test? Assuming that is not a horizontal line, which it isn't in this case. Yes? Good. All right. So we're going to say our guess is that this is going to be a prove one-to-one. Probably. We think so. I personally like the second one a little bit better, the second way of proving. So let's go ahead and do that, but we can do it either way. It doesn't make a difference. So prove one-to-one and use definition number 2. So that means we get to assume that F of X is not equal to F of Y. And I need to show that X is not equal to Y, right? That's my assume and my need to show. I get to assume that F of X is not equal to, why do I feel like those are backwards? Ooh, did I do them backwards on the previous slide? Hold please. Ooh, bad. Oh, I'm sorry. I did my definition backwards. We're gonna have to move the equals and the not equals around. I'm sorry. I'm hoping you're taking notes in pencil. Here we go. I'm erasing. Oh, that was very unfortunate. Okay, we're redoing the definition here. So, sorry. Go back and change your definition of one-to-one and what we're assuming. My bad, I'm sorry. This is where it would be easier to write on a board. Okay, so here's your change. I'm sorry, X is not equal to Y implies that F of X is not equal to F of Y. Or F of X equals F of Y implies that X equals Y. I'm sorry, the not equals should go with the X not equal to Y in the first hypothesis. Yeah, there's not equals on my paper there. Sorry, this is also why you need to go over stuff multiple times. So change your definition. X not equal to Y implies F of X not equal to F of Y, or F of X equals F of Y implies X equals Y. I'm sorry, it's Monday and I'm teaching online and I can't see any of you in person and I really would like to. Sorry. Thank you for being understanding. Okay, we got the definition fixed. I still like the second one better because then we have equals as opposed to not equals. So let's assume that f of x equals f of y, and I need to show that x equals y. Better, there we go. Assume that f of x is not equal to f of y, and I need to show, f of x equals f of y, and I need to show that x equals y. I quit. Okay, so here's what we get to assume. I get to assume that 3x minus 4 is equal to 3y minus 4. That's my f of x and my f of y. I get to assume that 3x minus 4 equals 3y minus 4. Give me a thumbs up, tell me that you're good with that is what we are getting to assume now that we've got the definition right. Awesome, okay. We don't do this very often, but we're allowed to. This is an assume equation, so I can work on both sides of it. If I wanted, I could start on one side of my need to show equation and work to the other side. I could if I wanted, but I have a ready-made equation here and I am allowed to work on both sides of it. So we can assume this, or we can say that 3x equals 3y if we cancel the minus 4 from both sides, or we can divide by 3 and say that x equals y. That's good. We'll go with as desired. And so therefore, f is 1-to-1. Yay. A lot of times, if you use definition number 2, you will get an equation where you want to work on both sides of it. That's okay. That's fine. As long as you have an equation that's true, you are absolutely allowed to work on both sides of it. If you have an equation that's not true, that you don't know is true, then you have to start on one side and work your way to the other. But if you have an equation that you know is true, you can work on both sides of it. All right, questions on this one before we try the next one? Anything? Okay. 2, 3, 4, and actually I miscounted, I have 5. Give me another number with fingers. 2, 3, 4, 5. Somebody hold up fingers. What do we want? Give me a number, pick. We're picking. Grace says 3. All right, for example, here's my function f. It is going from the real numbers to the real numbers, and it is sending x to x squared. This might have been the one that was in your reading assignment. So f is going from the real numbers to the real numbers, and it is sending x to x squared. So think about your graph. Graph of x squared looks like what? You should be able to draw this in the air with your finger for me. Graph of x squared looks like, we've got drawings, we've got pictures, parabola. Does that pass the horizontal line test? Yes or no? Passing the horizontal line test, we are shaking heads at no. So my guess is that this is not 1-to-1. Based on the graph, based on not passing the horizontal line test. Therefore, my guess is that this is a disprove. So I need to find, we can do either definition here. Let's go with the first one. So I need an example which makes definition number 1 false. Usually, not always, but usually, it's easier to use definition number 2 for a proof and definition number 1 for a disproof. Not always, but usually. So in other words, I need x and y living in the real numbers so that x is not equal to y, but f of x is equal to f of y, right? That's going to make definition number 1 false. Hypothesis true, conclusion false. Hypothesis true, conclusion false. All right, anybody who gave an answer in the reading assignment, feel like unreading yourself or typing it in the comments, either way, and giving me answers for x and y. Any answers that were given in the reading assignment were correct. We'll go that way. Anybody? Anything for x and y? What do you got?
X equals -2 and y equals 2.
Okay, so let's choose x equals 2. and y equals -2. Obviously, both of those exist in the real numbers. That's fine. And remember, whenever we are doing a disproof, there are 2 steps. We have to find a counterexample. We did that. And then we have to show that our counterexample works. So that's the second one. Then x is not equal to y. That's obvious. 2 is not equal to -2. But f of x is 2 squared, which is 4. And f of y is -2 squared, which is 4. So f of x is equal to f of y. So 2 steps. I found a counterexample, x equals 2, y equals -2, and then I showed that my counterexample worked. 2 steps. Find a counterexample, show that it works. And so we can say, therefore, f is not 1-to-1. Make sense on a disproof? Specific example, and then you got to show me that your counterexample works. Everybody good on a disproof? Give me a thumbs up. Yes, good. Happy there? Yes. All right, cool. We've done example 1 and example 3. While you're picking a number next, let me put my definitions back up here. X not equal to y implies f of x not equal to f of y. F of x equals f of y implies x equals y. So there's my definitions. Okay, 2, 4, 5. Somebody else hold up fingers. Grant and Grace have already picked an example. Thank you for participating. Lauren, 2. We are going 2. All right, this one's not a rule. It's an arrow diagram. For example, my set A is the set 1, 2, 3, 4. That should be curly bracket. 1, 2, 3, 4. And my set B is going to be A, B, C. And I'm going to do it in terms of an arrow diagram. So remember how an arrow diagram works. We've got 1, 2, 3, 4 over here. We've got A, B, C over here. And we are going to draw an arrow from 1 to A, from 2 to A, from 3 to B, and from 4 to C. So here's my arrow diagram. 1 goes to A, 2 goes to A, 3 goes to B, and 4 goes to C. Stare at that, think about your definition, and decide whether we think this is or is not 1-to-1. What do we think? Is or is not 1-to-1? I have people shaking their heads. No. I have some people still writing and still thinking. Shaking heads, thumbs down. We've got a bunch of head shaking. All right, so my question is, will you guess not 1-to-1? So I need a specific example. All right, so we're going to say let x equal what and y equal what? For the first one, what do we want to let x and y equal? So remember, these have to come from the domain, which is A, 1, 2, 3, 4. X equals what? Y equals what? Grant is saying 1 and 2. Okay, so if x equals 1 and y equals 2, so that's my counterexample, and then I have to show that my counterexample works. So both of those live in A, and then x is not equal to y, obviously, but f of x equals A, and f of y equals A, so f of x is equal to f of y. And therefore, f is not 1-to-1. Super. Doesn't matter whether it is or isn't. The point is that we guessed not 1-to-1 and our guess was actually correct. Super easy to tell with an arrow diagram. Really, really, really easy to tell. If you have 2 arrows pointing to the same output, not 1-to-1. 2 arrows pointing out the same output, not 1-to-1. Grant, question.
Was this a disproof?
Yes, because
Okay.
my guess was not 1-to-1. So since we're saying not, we did a disproof in this one, yes. We also know we did a disproof because we had a specific counterexample, I am not going to do an example with ordered pairs because you can easily turn ordered pairs into an arrow diagram if you want. So tell me that we're okay not doing an example with ordered pairs. We're good there? Same idea? Same idea? Okay, 2 more examples, and I want you to do these in breakout rooms. So 2 more that I would like you to work through. I'll give you both at the same time and then send you randomly into breakout rooms. We'll do randomly today. For example, F goes from the real numbers to the real numbers, and it is going to send X to e to the X. So you're going to need to think about what the graph of e to the X looks like in order to decide prove or disprove. F of X goes from the real numbers to the real numbers and sends X to e to X. That's the first one. And then my second one, F of X goes from the integers cross the integers to the integers. I got to give you a rule in a second. From the integers cross the integers to the integers. So this is going to take as input an ordered pair. We will call it m, n, and send it to 2m minus 4n. So your input this time, if you think that this is a disprove, and I'm not saying it is, but if you think it is, your input has to look like an ordered pair. So X would have to be an ordered pair and Y would have to be an ordered pair in order to do a disproof here. In order to do a proof, you're going to need to work with equations. Everybody got both of those. X goes to e to the X and m comma n goes to 2m minus 4n. We got both of those? All right, let me randomly put you in breakout rooms here. We'll do 2 of these randomly. All right, rooms should be open. I will pop in, probably give you about 5 minutes or so. So go ahead, join some breakout rooms and see what you got.
Do you mind resending me the
Yes.
link? It just kind of is way too far down and I can't select it.
Okay. Wait. Okay, now you should be able to. Breakout room 2. Oh, okay. You're fine. Okay. Either way, just pop into one. Use either link.
Oh. Well, I don't
Doesn't matter.